Hi friends, welcome to our YouTube channel Knowledge Academy. The meaning of this lecture is to discuss about the UPSC mains examination of the communication systems in a very detailed manner. If you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button. So whenever I upload a new video, the direct notification comes on mobile. If any improvements here in our lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. So why to waste more time? So let's get started. An AM wave 15 into 1 plus 0.4 cos 2 pi into 10 to the power of 3t into cos 2 pi into 10 to the power of 6t is to be detected by a linear diode detector. So first thing is find the time constant tau, and the second thing is find the value of R if the capacitor used is 100 picofarad. And this question is given in the IAS 2009 for the 8 marks. So this is nothing but a linear diode detector is also called as the envelope detector. So for this detector, if they are given the input is x of t, which is nothing but s of t am, then we need to find what is the time constant, and if the value of the find the value of R if the capacitor is 100 picofarad. So let's solve this numerical. So in the question they are given the s of t am. This is the equation they are given in the question. So we know the standard equation in AM is Vc into 1 plus Am cos 2 pi fmt into cos 2 pi fct. So this is the standard equation in AM. I have derived this one earlier in my previous questions. So if you compare these two equations, we are going to get Vc is equal to 15 volt and M is equal to 0.5 and Fm is equal to 10 to the power of 3 hertz and Fc is equal to 10 to the power of 6 hertz. This is what I have written here. So basically, what is the diagram of the envelope detector? So this is the diagram of the envelope detector. So when the input is s of t am, we are going to get output is which is purely message signal. So therefore here, the first one they have asked what is the time constant. So the time constant of the envelope detector is which is tau is equal to R into C. So this is the resistance and this is the capacitor. So this is the time constant. Always the time constant lies between the TC and TM, where TC is the time period of the carrier signal and TM is the time period of the message signal. So time period is inversely proportional to the frequency. So therefore 1 by Fc and 1 by Fm. So we know the value of Fc and Fm. So Fc is equal to 10 to the power of 6 and Fm is equal to 10 to the power of 3. So therefore tau, the time constant of the envelope detector, always lies between 10 to the power of minus 6 seconds to 10 to the power of minus 3 seconds. So therefore tau, the time constant always has to lies between these regions. So therefore tau is equal to RC we know, but actually the RC maximum, so RC always, the time constant always less than or equal to, this is a very fundamental equation in the communication systems, which is RC less than or equal to 1 by 2 pi Fm into under root over 1 minus m square by M. So I want to find what is the maximum value. So therefore RC max is equal to 1 by 2 pi Fm under root over 1 minus m square by M. So we know the value of Fm and we know the value of M. So substitute those things in this equation. So Fm is equal to 10 to the power of 3 and M is equal to 0.4. So if you substitute those things, finally we are going to get RC max is equal to means maximum time constant of this envelope detector is 3.64 into 10 to the power of minus 4 seconds. So therefore this is going to lie between these regions. So this is the maximum time constant this envelope detector can have. So therefore this is the maximum time constant. And the second thing is for RT max we already know, which is 3.64 into 10 to the power of minus 4 seconds. In the given capacitor is equal to 100 picofarad. So we need to find what is the value of the resistance. So by directly R into C is equal to 3.64 to the power of minus 4. We know the value of C, which is 100 picofarad, 100 to the power of minus 12. So by solving this equation, we are going to get R is equal to 3.64 mega ohm. So based on this first equation only, we are going to solve the second one. So basically, the time constant always going to lie between the TC and TM, and the maximum time constant is always lies between 1 by 2 pi Fm under root over 1 minus m square by M. So by using this formula only, we are going to get this one. So now we are going to solve the seventh question. See the question here. The RMS value of the antenna current before amplitude modulation is 10 ampere and after modulation is 12 ampere. Calculate the percentage modulation. Assume that there is no distortion. So therefore in the question they are given that the RMS value of the antenna current before modulation and after modulation, they are given the values. So based on this we have to find what is the modulation. So here they are also given that there is no distortion, means M is always going to lie less than or equal to 1, then only there is no distortion in the output. So let us solve this numerical. This question is given in the IAS 2011 for 20 marks. Now we will discuss the concept here. So IT is equal to current in antenna because of the presence of the both message signal and carrier signal. Means whenever we are going to give m of t and c of t, then the current which is present in the antenna, that current is said to be the IT. So therefore this is called as a after modulation, means current after modulation. And IC is equal to current in antenna due to only c of t, means when m of t is absent, means when m of t is 0, only c of t is present, that current in the antenna is said to be IC. So therefore here this is also called as a before modulation. So in the question they are given the after modulation the current is 12 ampere and before modulation the current is 10 ampere. So blindly we can say IT is equal to 12 ampere and IC is equal to 10 ampere. Always the IT current is always greater than the IC, means the current in antenna because of presence of m of t and c of t is always greater than the current in antenna only because of the c of t. So based on this, IT is equal to 12 ampere and IC is equal to 10 ampere. So power relation is nothing but power is equal to I square R. So this is the basic relation. So therefore PT is equal to IT square R and PC is equal to IC square R. Here R is nothing but the resistance of the antenna. So therefore here total power is equal to carrier power plus sideband power in AM is equal to PC into 1 plus M square by 2. So now I can rearrange this one in another fashion. So therefore I am going to get M is equal to under root over 2 into PT by PC minus 1. So therefore PT is equal to IT square R and PC is equal to IC square R. So if I solve this one, RR get cancelled. So therefore finally I am going to get here M is equal to under root over 2 into IT by IC whole square minus 1. So by using this equation only we are going to solve this numerical, because we know the value of IT current and also IC current. So blindly substitute those values, then we are going to get the M. So M is equal to under root over 2 into 12 by 10 whole square minus 1. So if you solve this one, finally we are going to get M is equal to 0.938 and percentage of M is equal to 93.8. In the question they also given that M is less than or equal to 1, then only there is no distortion in the output. So therefore we also got the value of M which is less than or equal to 1. So therefore there is no distortion in the output. So this is the way we can solve this numerical. So now we are going to solve the 8th question. See the question here. Evaluate the maximum and minimum values of V of t of the amplitude modulated voltage signal defined as V of t is equal to 10 into 1 plus 0.5 cos omega t plus 0.2 cos 2 omega t into cos of omega naught t. So for this we need to find what is the maximum value and the minimum value of the voltage signal we need to figure out. This is nothing but a AM signal. So this question is given in the IAS 2015 for 20 marks. So let's solve this numerical. So this is the voltage expression they are given in the question. So for this equation we need to find what is the maximum value and the minimum value of this function we need to figure out. So here let me assume that M of t is equal to this 0.5 cos omega t plus 0.2 cos 2 omega t. So let me assume this one, which is M of t. So therefore V of t we can write it as 10 into 1 plus this is M of t into cos omega naught t. So if you see carefully, this is the amplitude of the cos omega naught t. So if this is maximum, so therefore this is also maximum. If this is minimum, then also this is minimum. So therefore if V of t max, so these are the constant, this is all constant, only this is a variable, so depending on time. So if this is maximum, then only we are going to get maximum peak value. If this is minimum, then only we are going to get the minimum value. So therefore, so in order to solve this numerical, we need to find what is the maximum value of M of t and the minimum value of M of t, and then substitute those values in this equation. Then only we are going to get what are the maximum and the minimum values of this one. So now here M of t is equal to 0.5 cos omega naught t plus 0.2 cos 2 omega naught t. So for this equation we need to find what is the maximum and minimum value. So by using the calculus method, now in order to find the maximum minimum values, first we need to do the differentiation of this function is equal to 0, and then we need to find at what times this differentiation is equal to 0, and at that particular times whether it is going to have a maximum value and minimum value. Then we need to check, and then we need to substitute those values here. That is the agenda of this question. So here first I am going to do the differentiation of this M of t. So therefore I am going to get here cos omega t differentiation is minus sin omega t. So therefore omega I am going to keep here down. So therefore here also cos differentiation is minus sin 2 omega t. Here 2 comes outside. So therefore 0.2 into 2 is nothing but 0.4 by omega. So now I am going to equal to 0. So minus 1 by omega I am going to take it at common. So therefore this I am going to get finally. Then here omega cannot be 0. So therefore this has to be equal to 0. So therefore this is equal to 0, and here sin 2 omega t is nothing but 2 sin omega t into cos omega t. Then I got this expression, and then I am going to equate to 0. So in these two things sin omega t is the common, so therefore sin omega t I am going to take common, then I am going to get like this. So therefore sin omega t is equal to 0 and 0.5 plus 0.8 cos omega t is equal to 0. So therefore if I equate sin omega t is equal to 0, then I am going to get t is equal to 0, and if I equate this to 0, then t is equal to 1 by omega cos inverse of minus 5 by 8. These are the two instances I got. So at these two instances I am going to get dm of t by dt is equal to 0, means differentiation of the m of t is equal to 0 at this particular two instant time values. So then we have to find at this time instance whether the function is increasing or decreasing, we need to figure out. So therefore now we need to do again the second differentiation. So with the first differentiation equation we already know, we did this one. For this one we need to do the second differentiation with respect to time. So this is the equation we are going to get. So for this one I need to substitute at t is equal to 0. At t is equal to 0, if I substitute here, cos 0 is 1 and cos 2 into 0 is again 1. So therefore this is the equation I am going to get here. So finally minus 1.3 by omega square. So omega square is always a positive and 1 by 3 is always positive. So there is a negative sign. So therefore finally d square m of t by dt square at t is equal to 0, we are going to get a negative value. Means whenever the second differentiation is negative at a particular time instant, then we are going to get a maximum value. So therefore at t is equal to 0, we are going to get m of t as a maximum value. So therefore at t is equal to 0, we are going to get the maximum value, and then again we need to check at this condition also. So now similarly for the second derivative we need to find at t is equal to 1 by 4 cos inverse of minus 5 by 8, we need to find what is the value, whether it is a positive or negative value we need to find. So therefore we can write it in this fashion also, cos omega t is equal to minus 5 by 8. So wherever cos omega t is there, just substitute minus 5 by 8. So therefore here minus 5 by 8. So I got this one. So this is cos 2 omega t is nothing but 2 cos square omega t minus 1. So the 2 cos omega t is minus 5 by 8 whole square minus 1. So if you solve this one, we are going to get finally, this is the thing we are going to get 3.9 by 8 omega square. It is nothing but a positive value. So whenever the second derivative is a positive at a particular time instant, then at the time instant this m of t is going to have a minimum value. So therefore here this is going to have a minimum value at this instant. So finally we can conclude that at t is equal to 0, we are going to get the maximum value of the function, and at t is equal to 1 by omega cos inverse of minus 5 by 8, then we are going to get the minimum value. So therefore we need to find these two values at this particular instant. So now I am going to find what is the maximum value at t is equal to 0. So m of t function we know, just at t is equal to 0 we need to substitute. So whenever t is equal to 0, cos 0 is again 1 and cos 2 into 0 is again 1. So therefore 0.5 plus 0.2 is equal to 0.7. So therefore we are going to get the maximum value of m of t is 0.7, and similarly now minimum value of m of t we need to find at a particular instant. The instant values, this is the instant. So therefore t is equal to 1 by omega cos inverse of minus 5 by 8. We can write in this fashion also, cos omega t is equal to minus 5 by 8. So wherever the cos omega t is there, we just substitute minus 5 by 8. So therefore here cos omega t is minus 5 by 8. Cos 2 omega t is nothing but 2 cos square omega t minus 1. So therefore 2 cos square omega t minus 1. So cos omega t means minus 5 by 8. So if you solve this one, we are going to get 0.3563. So this is the minimum value and this is the maximum value. But we know v of t max is equal to 10 into 1 plus m of t max. So we know the m of t maximum value, which is 0.7. So therefore substitute 0.7. So 10 into 1 plus 0.7 is nothing but 17. So therefore the voltage V of t is going to have a maximum value of 17, and V of t minimum is equal to 10 into 1 plus m of t minimum. We know the value of m of t minimum, which is 0.3563. So in place of m of t minimum minus 0.3563, if you substitute here, then finally we are going to get here 6.437. So finally I can conclude that the voltage maximum is 17 and the voltage minimum value is 6.437. So now we are going to solve the 9th question. See the question here. The antenna current of a transmitter is 11.5 amperes when it is modulated to a modulation depth of 45% by an audio wave. The current enhances to 12.5 amperes on account of simultaneous modulation by another audio sine wave. Find the modulation index of the second audio wave. So in this question they are given the transmits antenna current at a one wave, means the first message signal. For that message signal with respect to carrier, we got the current IT. And similarly suppose the message signal, there are two message signals now. So we are going to add extra message signal. So because of these two message signals and carrier, the current in the antenna is also they are given. So the first wave modulation index is also they are given. Now we need to find what is the modulation index of the second wave we need to figure out. So this question is given in the IIS 2018 for 20 marks. So let's solve this numerical. So now as a transmitter, when you are going to the message signal M1 of t and the carrier is C of t, this is the antenna. So the current in the antenna is IT1. So basically the IT1 is equal to current in the antenna because of the presence of M1 of t and C of t. So when these two signals are present, then the current which is flowing in this antenna is called as the IT1. So therefore this is the IT1 antenna current. So therefore IT1 is equal to, they also given which is 11.5 ampere. And IC is equal to the current in antenna because of C of t only, means here M of t, M1 of t, the message signal is absent, means it is 0. So when only the C of t is present, then the current in the antenna is said to be IC. So therefore current in antenna due to presence of only C of t only. So therefore R, this is the resistance of the antenna. So this is the resistance of the antenna. In the question they also given the modulation index of the first signal, means M1 of t, it has a modulation index of 0.45. So now here, so PT is equal to, P is equal to I square R. So therefore PT is equal to IT square R and PC is equal to IC square R. So this is the total power and this is the carrier power. So therefore PT is equal to PC into 1 plus M square by 2. Here M is nothing but here M1, because we are going to use only the first signal. So therefore here M1 square by 2. So therefore PT is equal to IT square R and PC is equal to IC square R. And R is common. So therefore we are going to cancel this one. So therefore this is the equation we are going to get finally. So if R is cancelled, so then we are going to get this equation. So here IT is 11.5 whole square and IC we need to figure out, and M1 we know which is 0.5. So if you substitute those values, we are going to get IC, the current in the IC antenna because of C of t only is 10.96 ampere. So by this we have figured out what is the current in the antenna because of C of t. Now let's come to the second case. For this AM, they also given that we are going to apply the another new audio message signal, means M2 of t. So along with the M1 of t, there is also another signal which is M2 of t, and the carrier is still the same. Then this is the current. So therefore I2 of t is nothing but the current in antenna due to presence of M1 of t, M2 of t and C of t. So because of three presence, the current in antenna is said to be I2 of t. I22. So therefore I22 is equal to current in antenna due to presence of M1 of t, M2 of t and C of t. So therefore this is, they also given which is 12.5 ampere. So now IC is equal to current in antenna due to presence of only C of t, but not M1 of t and M2 of t are absent, means 0. So but we already know which is IC is equal to 10.96, because here the current in antenna because of presence of only C of t, but the message signals are purely absent. So same case in the second case also, for first case also. So therefore IC is equal to 10.96, which are taking from the previous case, and M is the overall modulation index of these two signals. So because of these two signals, the overall modulation index is M. But in the previous case there is only one message signal, so therefore the modulation index is M1. But here there are two signals, so therefore the overall modulation index is M. So therefore PT is equal to PC into 1 plus M square by 2. So PT value we know which is I22 square R and PC is IC square R. So RR get cancels. So we know the value of I2 which is 12.5 whole square and IC is 10.96 whole square and 1 plus M square by 2. There is only one equation with one unknown. The unknown is M. So if you solve this one, we are going to get M is equal to 0.775. So this is the overall modulation index. But we need to find what is the modulation index of the second message signal we need to figure out. So basically here the overall modulation index is nothing but square root of the M1 square plus M2 square. This is already I have explained in the some of my previous examples also, because here the overall modulation index is always, suppose there are n message signals, means under root over M1 square plus M2 square up to Mn square, up to n message signals. First message signal modulation index, second message signal modulation index, and up to n message signal modulation index. But here there are only two message signals, so therefore under root over M1 square plus M2 square. We know the value of M which is 0.775, and M1 also we know the first signal modulation index is 0.45 whole square and M2 square. We need so only one equation with only one unknown. The unknown is M2. So therefore M2 is equal to 0.63. So therefore 63% % is the modulation index of the second audio signal or second message signal. So this is the thing we need to figure out in this question. So now we are going to solve the last question of this lecture. See the question here. If x of t is equal to cos 200 pi t, determine AM transmission bandwidth and average transmitted power for the AM modulated signal where AC is equal to 10 volt and modulation index is 0.6. So what will be the values of the BT and ST in the case of DSB transmission? So here in the question they are saying that for the AM what is the bandwidth and the average power, and for the DSB dual sideband then what is the bandwidth and the average power we need to figure out when the message signal is x of t, and also they are given the peak value of the carrier signal which is 10 volt and modulation index is 0.6. So from this data we need to find what is the bandwidth and the power in the AM and bandwidth and the power in the DSB we need to figure out. So let's solve this numerical, and this question is given in the IIS 2012 for 10 marks. So let's solve this numerical. So this is the message signal x of t is equal to cos 200 pi t is nothing but we can write in this fashion, cos 2 pi into 100 t. The basic m of t is nothing but cos 2 pi fmt. So if you see this one, so therefore fm, the message signal frequency is 100 Hz. And here the carrier signal is Vc cos 2 pi fct. In the question they are given the peak value of the carrier signal. See in the question they have assumed Vc is equal to AC, but generally I used to assume Vc is nothing, so Vc is equal to AC. So Vc is the peak value of the carrier signal. This is the notation I am going to use here. So Vc is equal to 10 volt and the modulation index, in the question they are given mu, but generally I am going to assume m is a modulation index, so therefore m is equal to 0.6. So for this equation, so for the AM signal what is the bandwidth and the power, and for the DSB signal what is the bandwidth and the power we need to figure out. So AM is nothing but AM, so therefore here Vc plus x of t we need to add. So basically this is a standard equation. So finally we are going to get this is a standard equation which is Vc into 1 plus m cos 2 pi fmt into cos 2 pi fct. This I have already told you so many times previously also. So therefore here this is the standard equation. So therefore here now I am going to multiply this one inside. So Vc cos 2 pi fct plus mvc cos 2 pi fct into cos 2 pi fmt. So therefore this is cos a into cos b. So we can write here 1 by 2 cos of a plus b plus cos of a minus b. So this by using this notation I have simplified in this manner, and then I am going to multiply this mvc by 2 inside to this 2 cos term. So therefore finally this is the equation I am going to get. And if you see carefully, the frequencies which are present in this s of t am are fc, fc plus fm and fc minus fm. So fc plus fm and fc minus fm, these are the three frequencies which are present in the AM. But if you see carefully, the highest frequency is fc plus fm and the lowest frequency is fc minus fm. So bandwidth is nothing but highest frequency minus lowest frequency. Highest frequency is fc plus fm and the lowest frequency is fc minus fm. And if you do subtraction we are going to get 2fm. fm value we all know which is 100 Hz. So therefore 2 into 100 is nothing but 200 Hz. So therefore the bandwidth in the AM signal is 200 Hz. Now we need to find what is the total power. So total power is nothing but RMS value of the each signal whole square we need to do. RMS value of the each signal square we need to do. So this is the first signal, second signal and third signal. The RMS value of this signal is Vc by root 2. We need to do the square. And similarly the RMS value is MVc by 2 by root 2 whole square. And for this also MVc by 2 root 2 whole square. So this is the for each signal RMS value we need to figure out, and then we need to do the square. Then we are going to get this equation finally. So we know the value of Vc which is 10 and m is equal to 0.6, and if you substitute all those values here we are going to get 59 watt. So 59 watt is the power which is going to send by this signal, 59 watt. And similarly for the S of DSB, S of DSB is nothing but product of the message signal and the carrier signal. So this is Vc cos 2 pi fct into cos 2 pi fmt. So here now same cos a into cos b is nothing but cos a plus b plus cos of a minus b by 2. So therefore by using that manner I have made this one, and I am going to take this peak value inside to the 2 cos term. So therefore this is the equation finally I am going to get. And if you see carefully, there are only two frequencies which are present in this DSB, which is fc minus fm and fc plus fm. There is no fc term which is present in the DSB. So highest frequency is fc plus fm and lowest frequency is fc minus fm. So bandwidth is nothing but highest frequency minus lowest frequency, which is fc plus fm minus of fc minus fm. It is nothing but 2fm. fm value we all know which is 100 Hz. So therefore 2 into 100 is nothing but 200 Hz. So this is the bandwidth of the DSB signal. Now we need to find what is the power. Same thing, RMS value of the S signal square we need to do. So there are only two signals. So RMS value of the first signal is Vc by 2 root 2 square we need to do square. And similarly the second signal also Vc by 2 root 2 whole square. And if you do this one, we are going to get Vc square by 4. We know the value of Vc, which is 10. So 10 square by 4 is nothing but 25 watt. So finally, we have calculated the bandwidth and the power in the AM and the bandwidth and the power in the DSB. So the bandwidth in the AM is 200 watts and the power in the AM is 59 watt. And the bandwidth in the DSB is 200 watts and the power in the DSB is 25 watt. So if you see carefully, the bandwidth in the final, we can conclude that the bandwidth in the AM is equal to bandwidth in the DSB. But power in the DSB is always lesser than the power in the AM, because in the DSB there is no presence of carrier signal. So because of that reason only, the power in the DSB is less when compared to the power in the AM. So by this lecture we have successfully completed the 10 questions which are the previous year questions of the UPSC mains examinations of the communication systems in a very detailed manner. If you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button. So whenever I upload a new video, the direct notifications comes in mobile. If any improvements needed in our lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. Thank you so much for watching this lecture. Keep smiling, take care and bye bye.